All right, it is almost 2 p.m. Eastern Time, and we are about to begin the first annual MIDCA Workshop here at Wright State University with the Collaboration and Cognition Lab. Just before we begin, so my name is Dustin Dannenhauer, and our lab, along with Mike Cox and Zora Dannenhauer and a number of our other students, which you'll all see, are going to be giving this presentation. We're really excited to be doing this on YouTube Live. It's our first time doing a presentation like this. So we think we have all the technical difficulties ironed out, but if anything happens, just bear with us. There is a chat box on the YouTube video, or next to the YouTube video, so if you have any questions at any time, just type into the chat box. We will address them, and we'll include. There's a little bit of a delay, so if we don't get to your question right away, don't worry. And before we begin, I just want to thank NSF, ONR, the Air Force Office of Research, and the Army Research Office for providing funding to MIDCA over the years. And I also just want to thank all the people who have contributed from Wright State University, Lehigh University, and the University of Maryland. And let's get started. So,
slides will be available.
Oh, the other announcement is that we are going to have slides available next week. So, if you're only able to catch part of the presentation, don't worry, we'll have more of it later. We'll have the whole thing next week. So what are the objectives of this workshop? So for us, we want to have this to bring everyone up to speed on the current capabilities of MIDCA. We have a lot of interesting directions happening right now. We also want to brainstorm ideas for improving MIDCA and new research paths. There's a lot of areas we can explore. And we have some new students in our lab, and so what we want to do is we wanted to learn how MIDCA how easy it is for a new user to start using MIDCA, so we're going to have a short presentation on that. And then we also just want to further establish a community around MIDCA. This is an open source cognitive architecture, publicly available, and we want to strengthen resources. So we hope that these slides and these presentations will be helpful for anyone who wants to play around with MIDCA, use MIDCA for research, etc. So today, this is what we can look forward to. So right now I'm giving an introduction. In about 10 minutes or so, Dr. Mike Cox will talk about the origins of the MIDCA architecture. He is really the father of MIDCA. We're going to have a presentation on the goal graph and goal operations by Shravya. Then we will have a demo and a few slides from Vahid on using MIDCA and Baxter and Gazebo, which is a simulation. Then we're going to take a coffee break and a collaborative brainstorm break. So for those times, for the coffee break, we'll pause the stream. And then we're going to talk about planning. So the session from like 3:35 to 4 is really all about planning. And then we start talking about like acting and perception. And then we'll talk about metacognition. And then we'll have the new user experience. And then we will have a working session and closing thoughts. So this workshop is meant to be informal. It's a chance for all of us to talk about MIDCA, ask questions. No question is, too simple, or so any questions are good. And we're looking forward. So this is what today will be like. Now, I'm just going to talk a little bit about MIDCA and set the foundation for us. So what does MIDCA stand for? It is the Metacognitive Integrated Dual Cycle Architecture. Designed from the beginning for metacognition, the dual cycles refer to both cognition and metacognition. And we have both an architectural model, a theoretical formalism, and a running implementation. So the cognitive phase, you will see this picture a few more times. It essentially has 6 phases. On the lower right, we have perceive, which is the agent perceiving the world. Then we have interpret, which is interpreting the percepts of the world, inferring new facts, instantiating a domain model, and also generating goals. And then we have evaluate. So evaluate is evaluating the current status of the agent, how it's doing in achieving its goals, how correct is the domain model. and some other things. And then we go to the other side. So this is the problem-solving side, where we have intend. So intend chooses which goal or goals the agent will pursue. Plan generates a plan to achieve these goals, and then act begins executing those actions. There's no start place because this is really a cognitive loop that will keep running, and all of these phases will use memory, MIDCA's memory, so that which has things. You may not be able to read the text. I'm not sure about how the resolution is on the stream, but in the memory we have mission and goals, we have the world model, episodic memory, semantic memory. Some of these are still part of the theory. We haven't implemented them yet. And so all these phases can use the memory. So just like we have a cognitive layer, we have a metacognitive layer. So instead of perceiving and acting in the world, the metacognitive layer is perceiving and acting on the cognitive layer. So monitor is like the cognitive perceive, except that it's getting data about the cognitive layer instead of the world. And likewise, we have a similar cycle. And we'll see more about this later. So these are some of MIDCA's publications. There's a paper coming out in IIII 17, Goal Operations for Cognitive Systems. So we explore you to look into these if you want to know more about MIDCA and what we've done. So now I'm going to talk about using MIDCA. So MIDCA is on GitHub. This is the URL, mclumd at MIDCA, and we use Python 2.7 right now. And we have the wiki. So most of the documentation is on the wiki, on the GitHub page. So if you go to GitHub and you look at the MIDCA project, this is what you'll see. And if you click this MIDCA version 1.4 home, you'll start getting the information on how to download and run MIDCA, how to run the examples. We have stuff about how to add new domains, and there's also contact information there. So I'm going to just take a quick second to talk about the code base. This is particularly helpful for some of us who haven't really worked with MIDCA yet. Really, in the core of MIDCA, there are these three files: base.py, goals.py, and mem.py. These are really like the core of MIDCA. Base.py has a lot of the structure of the phases and the modules and having them run in cycles. And goals has the goal graph and the goal representations. And memory represents how MIDCA's shared memory. And then some of these other files are used, but really if you're going to get to know MIDCA's code base, these three, probably even base.py is what you want to start with. Now, the limbs of MIDCA, just a loose descriptor, really what you would want to look at from the most important limbs would be the domains, the examples. So examples are the startup scripts that run MIDCA. We have modules, which are the cognitive layer phases in their implementation. And then we have meta modules, which is the meta layer. And then we have the world simulator, which also contains MIDCA's internal state representation, operators, actions, predicates, atoms, etc. So just to give you an idea of what's in some of these, the domains, we currently have MIDCA running in 4 domains. Some of those domains have multiple variations. We have a chicken versus road, very simple domain as a tutorial to get used to working with a new domain in MIDCA. Then we have blocks world. We have variations of blocks world, arsonist, mortar. Mortar is something that you stack in between blocks to make sturdier towers. Some of these are in some of the publications. We recently added a new domain, nbeacons. So nbeacons is part of my research. And it's essentially a Mars rover-like world where an agent moves around on a tile grid and has to activate beacons. And it's a dynamic domain. And so we have a variation of that with wind change. And then we also have both a physical Baxter here in our lab that we use. There's also one at the University of Maryland. And we also have Baxter in a gazebo simulation, so you'll see a demo of that later. So we use MIDCA on both a simulated and a real physical Baxter robot. The examples. This is just a list of the example scripts that we have. So all of these run MIDCA with differently configured settings in different domains. Then we have modules. So this is where the code is for the phases. So I mentioned briefly we have the perceive, interpret, evaluate, and then we have intend, plan, act. They are found here. Now, Planning has most of the planner implementations, etc. So this is where you wanted to explore if you want to use some of the modules. Okay, and then I didn't talk about WorldSim. WorldSim has MIDCA states and operators, and we will have a slide on that a little later. So I just want to show you some code. This is a down-to-earth presentation. So thank you. This is a code segment from a startup script in the examples folder. So I just want to show you, this is how we create a MIDCA. So we create a MIDCA object, which is something from base.phaseManager. And then we add phases by name in the order that we would like. So we have, for any simulated domain, we have, and this example is a simulated domain, we have a simulate, which is kind of like it's like a simulated world we can interact with. Then we have perceive, interpret, evaluation. We added the cleanup phase here, and then we have intend, plan, act. So this is not hard set in the architecture. So if you need to add a phase or like an in-between phase, you have the freedom to do so. And then we add modules. So this is an important note for anyone looking to work with MIDCA. Phases are collections of one or more modules, and a module is what does the cognitive reasoning that we are doing. So for example, in interpret, I mentioned that we might do things like anomaly detection and goal generation. Well, in that case, we might have multiple modules in the interpret phase. And so here we just show one, but if you have multiple, you can specify the order in which they should be executed in that module. So that way you can perform anomaly detection, explanation, and goal generation all within the interpret phase. And then we have the same thing for metacognitive phases. This is a recent addition to the architecture within like the last year-ish or so. And just like we add modules at the cognitive layer, up here, we just do the same thing, and I don't show it here, but that's what it looks like. So this is just, if you look at an example script file, this is what you'll see. The other things that are in a startup script, we load the domain and state files, we set a display function for the human to be able to view it if they're running it in simulation. You can toggle things like storing the memory values at each phase and logging, and you can also specify the goal graph and how to compare goals across the goal graph. So what does a MIDCA look like in action? So when you're running in a simulated domain, at the top left here you have the visual representation for the human, and then for the human using this, and then you see that it's going through each of the phases, going through perceive on the left, then interpret, it's inserting a goal, then it's going to evaluation isn't doing anything, it goes to intend, it chooses the goal that was generated in the previous interpret phase, and then planning. And then planning computes a search. This is using a heuristic search planner, we have other planners, and we get a plan, and then we start executing it. So this is what it looks like if you're going to start running it. And that is the end of my introduction. We are excited for the rest of the talks. I think we have about a minute. If there are any questions, or anyone from YouTube, or anyone here that has any questions or anything? Do we have anyone from YouTube logged in? Yeah. We do. Cool. Yeah, maybe during the coffee break or something we can find out who it is. We'd like to know if there's anyone. Yeah. So thank you for being with us, and we're now going to move on to Mike's talk.
So I would like to know how could you differentiate here the difference between the cognitive actions and artificial intelligence, because I feel that it is more related to artificial intelligence, because the program you have the function modules like plan, act, intent, others. It's similar to the way the robot functions. But as far as I know, the cognitive since cognitive is nothing but how a human perceives, how can human gain knowledge? So that's my question.
So we, just for those of you who are joining us live, we have a question about how is this cognitive relating to like human cognition versus artificial intelligence. This is, so I will attempt to answer your question, but Mike might be better able to answer your question. So this is a cognitive architecture. So it has some of the faculties that in a computational format that humans have. So humans can plan, they can select goals, they can achieve those goals in the world. And so this is a cognitive architecture, a program, in an attempt to realize some of those functionalities. And so some of it's based off human cognition, some of it, but yeah, it is probably, in your question, it's probably closer to artificial intelligence. Yeah. Thank you for that question. Yeah.
Matt asked, are there examples we'll see with metacognitive side?
Yes, I will show an example of the metacognition, and I'll go through all the metacognitive capabilities, and I'll show one demo of the metacognition, at least.
After the
Yeah.
first coffee break, right?
Yeah, so after the first coffee break, later on in the schedule, we will have, I'll have a 20-minute talk on metacognition. So we're going to transition to Mike now.